Hi, my name's Barbara Harrington. Today's date is February 11th, 2018, and this week we're going through respiratory physiology. So normally in the hospital when we measure patients' total oxygen volume, we're using a spirometer. It's often practiced too with asthmatic patients, COPD patients, to help them with their total lung volume. We don't have that right now, so instead we've been practicing with a balloon on our measurements. The first thing we did to get our normal breathing measurements is I just set my timer for 30 seconds, like I'm gonna do right now, and I'm just gonna count the number of breaths I did with 30 seconds. All right, now we go through 3 trials of this. The first trial, I got 7 breaths in 30 seconds, which would be a total of 14 breaths per minute. We add up all of the trials. As you can see here, we have 7 plus 6 plus 6, and then we got the average of the trials, which was 6.33. And then we multiplied that by 2 to get our average breaths per minute. Next, to get our total volume measurements, this is just my volume at rest. So I'm going to take a normal breath and breathe out into the balloon. So I'll stretch a little bit. Okay. Then I'm going to measure, so the circumference around the balloon, and I'm at about 48.5 for my first trial. Then to get the radius with our circumference, we took our average, because we did this 3 times. We took our average of our circumference during our 3 trials. We added them all up and divided them by 3. And then we did, as you can see here, I did circumference, which the average circumference was 48.5, divided by 2 times pi, which is also 6.28, which gave us our average radius at rest measurement of 7.72 centimeters. Then, once we have our average radius, we can do our tidal volume at rest. So we do 4 times pi times radius to the 3rd divided by 3. So I just kind of wrote it out, and I got 5,778.73 divided by 3, which gave us a volume of 1,926.2 mLs. And that is my tidal volume at rest. Once we have the tidal volume at rest, we can also figure out our minute volume at rest, which is tidal volume at rest times average breaths per minute divided by 1,000. So I plugged in what I got with my tidal volume at rest, timesed it by my average breaths per minute, which we did in the beginning of the exercise, and it was 12.7, divided by 1,000, which gave us 24.5 liters per minute is our minute volume. Later on in the exercise, we measured my height, my weight. We got an estimate of the full volume force vital capacity, and also my estimated lung total volume. And then we also tested my lungs and total tidal volume with doing exercises such as I was doing jogging in place for 30 seconds, along with doing some burpees, and then counted my reps, my breath rate after that for that 30-second go around. And then I also blew into the balloon to see what my total tidal volume during exercise was. The same way we figured it out during rest. Thanks for tuning in this week, and I'll see you next week.